across different clusters, different clusters using this paradigm. Okay, right? I want the Vijayanagaram campus. Who is the person there? Can you identify your name, please? The teacher.
Venkatesh.
Can you? Venkatesh. Okay. So Venkatesh, you will be in charge of this experiment. Okay. I'll explain this experiment now. This is also part of the, okay. Okay, let me also go across to Gudlavalleru College, okay, and come back to you, okay, before I explain the experiment that I want to do, okay, yeah, okay. Okay, so any other college is publishing its video. I just want to go across. I think we will stop the interaction here now with this college, okay. But I think Gudlavalleru College, there are no students, I think. I can still go across. Let me still do that. Go across to this college, okay, and see the. Yeah, is this Gudlavalleru College? Who is there now in this college? Is a teacher present there? Hello? I'm not getting a voice back from this college. Hello? Hello? Are you listening? Are you able to get my voice? I think they have actually gone off. Okay. Any other college putting the putting the video across? I want to talk to them. Explain, what before we get on to Hadoop and showing you how to run programs using the Hadoop, which will be done by the people. Are we ready? Or all the people around? Is there any other college publishing the video, please? In particular, I wanted to actually interact with this Gudlavalleru College. I think they got this Vishwa software previously. Okay, are you ready for the interaction? This college? Yeah, let me go across and then interact with this college again. Okay. Yeah. See, have you got your mic on, or mic is still not working? See, I know that this college actually has got the Vishwa platform, Vishwa software installed for you long back. Okay. You got this Vishwa software. Have you been able to use it? Have you been able to use? We had given it to you. Okay, so I don't know who is the person who got it. In fact, 3 of our students came to your college and then installed this software for you. What I'm going to do is, can you this experiment will involve now across the colleges. As I was telling, this experiment now involves multiple colleges, and we actually looking at all the colleges participating in this to be able to connect it up using the cloud. Okay, let me show what is the experiment that I want you to understand and do it. This is something that can help you also think of cloud in a different way. Okay. I'm actually sharing the desktop now. Just look at the website that this is our lab website. Okay, dos.iatm.ac.in. This is the lab website that you are looking at. In the research section, go to the distributed systems. Then you see at the end this Vishwa, a scalable, reconfigurable peer-to-peer grid middleware. Okay, if you go here, you will see a dynamic reconfigurable peer-to-peer grid middleware. Okay, this allows you to connect up multiple computers on which you can put them all together, and you will be able to write a program that works parallelly on all these machines. Okay, now if you go here and see how to get started, okay, you can will run on Windows machines, this will run on Linux machines, this will run on Mac machines, this will run on all the machines. Okay, now this is just in 7 steps you can actually configure your grid. In fact, there are students who configured in 7 steps up to few hundred machines together and have written programs that run on these few hundred machines. Okay, it's very easy to get, using this. If you get into these steps, it gives steps common for both Windows and Linux. Actually, require one journal server and few grid nodes. In this case, what is shown here is 3 grid nodes and 1 client node as part of this. The grid nodes can be any number of grid nodes. Here it can be 100 to 1000 grid nodes, whatever you want to set up in a campus. If you have all the machines, you can connect them up together and do parallel programming using this. Okay. As a step 1, what you have to do is you have to go to our site and download 2 files, the jvishwa.jar and journal server.jar. Okay, and there are sample programs like this prime.zip which you can download, extract these files from our this thing. Okay, assuming that you have created a Vishwa directory, what you need to do is this file jvishwa.jar is required on all nodes except the journal server node. Okay, this is journal server.jar will be required on the journal server node only. Okay, you will have this prime number between 2 given integers. You can calculate all the primes. This program is written in this prime client.java. Okay, the prime.java is actually the prime calculation program. Okay, right? You should realize is following steps are same in both Windows and Linux. Only step 6 and step 7 there is a difference which is mentioned in those steps, because we are using the Windows, the paths and all those are different. Okay. Step 3, you will set up a journal server. Setting up the journal server is very easy. What you're going to do is you're going to pick a machine which you want to make it as a journal server. You're going to run this program java -jar journal server.jar. Okay, here this is what it will ask. You're asked here to enter a journal server ID, enter any integer number. Okay, if this is the first journal server you're setting up, enter 0. There can be multiple journal servers, they all can work together. Okay, but right now you can configure it for the first machine as the journal server on which you are. If you put 1, it will give you the adjacency table which will be used for looking at how the other grid nodes are all connected together in terms of access points. Okay, if this comes up, it means that you have successfully started the journal server. At any step, press 1 and enter to check the adjacency table, which gives what are the number of grid nodes that actually have gotten together, who is closer to whom. Okay, that all that information you can look at. Now, once you have got the, for example, here, since nobody else is present at this point of time, when you press 1, there's no other grid nodes present. So, number of rows will be 0. If more and more grid nodes join, then you start seeing that information here. In the step 4, you can start a grid node. To start a grid node, make sure you have downloaded the jvishwa.jar file. Execute the following command at the shell prompt. Same thing, java -jar jvishwa, but give this number here which is the journal server's IP. Okay, note that is the IP address of the journal server that we have started in 3. On whichever machine you have started this, you should use that machine's IP address here so that this machine gets connected. Okay, journal server reply message is received. It took so many seconds. Is that this is the thing that it will give you. Routing table -1, neighbors 2, leaf set, all this will give you. Okay, node ID is 5. Okay, if everything you have done is right so far, you should get the above output at the shell level. Okay, if you get the following exception, then either you have given a wrong IP address of the journal server or you have forgotten to start the journal server. Please check. Correction refuse, blah blah blah, all this stuff. Okay, if you have succeeded in starting the node, you can also check the same by going back to the journal server node and giving input value 1 to the adjacency table. Now here you can give 1. Here it shows, for example, in the case of adjacency table, you have added a new machine here, 10.6.9.44, new node of the IP added. Okay, that will be visible now here. Okay, you can add as many as you want. Okay, number of rows is 1 here. Okay, step 5, you can start more grid nodes on whichever machine you want to run, including a Windows machine or a Linux machine. You can start this grid. Okay, basically once you start the same thing, now you will get, for example, here the row 1 has all this, as you can see. Okay, there are 3 machines. It is giving you which are all the machines that are closer to each other. So the total number of rows is 3. So I've added 3 machines into the grid. So it's very easy to set up a grid, okay, using this. Above you can find 3 grid nodes with IP address 10.6.9.44, 10.6.9.27, 10.6.9.7. So you can check the routing tables and all that. So this simply you can set up the grid now. Using this you can, now these nodes are a part of this. Now you can run programs across all these machines that got connected up. For example, in this case, there are some sample programs. One sample program we show here is a prime.zip using the client node. Okay, so what you get here is, for example, this example calculates prime numbers between 10 lakh to 100 lakh or 1 million. Okay, 10 lakhs to possibly 1 million or whatever it is. Okay, now prime client.java, it contains the code to initialize the client manager of the grid to submit the task to the grid. Okay, please make sure you are not running the client node on any of the grid nodes. There is a restriction here. The client node on which you are running this program should be different from all the grid nodes. Okay, right. So it also collects back the subtask results and then gives it, the whole results will be stored in this prime result.txt. Okay. Now you can see a prime.java. It contains the actual logic to calculate the prime numbers. This class is loaded into the grid nodes that are executing the subtask by the client manager. Okay, we have to do slight reconfiguration here. Okay, for example, here in the prime client.java file, you have to edit it. For example, here you should see the set minimum donors, how many grid nodes you want. This is set to 2 here. If you have at least 2 nodes should be there, otherwise the program will not run. Set maximum donors to 3, which means that the maximum it will take for computations is 3. Okay, set the replica size, which are all the places where you want the data to be replicated. This is set to 1. Okay, now the most important part where you should be changing this is set grid node IP. The grid node to which this task should be submitted is to be given here, 10.6.9.44. This should be changed to whatever grid node you have in your setup. Okay, the rest will all be the same. Okay, compile and run the program. For example, in this particular case, you will run the prime client.java. As you can see, this is a grid node where you will compile it. In Windows machine, the class paths are going to be different, so you will use a different command for running the compiling it. Once you have compiled, if you have a class file, then you can directly run it. Okay, then you will see once you have successfully compiled, then you see this prime.class and prime client.class. Okay, Now what you can do is you can run this program. Once you submit this program now, it automatically gets submitted. Okay. Once the program starts running, it says minimum number of nodes is 3, maximum number of nodes is 4. Press any key to start the execution. So you can press any key, but after that don't forget to press an enter. Only after you press an enter, it starts running. Okay. If there are no sufficient number of nodes that join the grid, then it will give you this error, insufficient nodes. Okay. Otherwise, it will give you this output. Press any key to start uploading the file through FTP. Okay. Download successfully the results. This all will happen on your program. It will make it into sub programs, and the final result will be there in the txt file for you. Okay. Prime results.txt on your node will have the results for all these prime numbers. Okay. Is this clear? There's simple 7 steps in which you can set up your grid. This is actually being used by a number of colleges, including Tamil Nadu, and some colleges in Germany use this software. Okay. For some reason, I have not personally popularized. It would have required me to give a lot more. This is available since 2009 or 10. It looks very similar to Hadoop kind of a model, except that here you won't have the file system. Hadoop has a file system on which you are doing the parallel programming. Here is the case. This, please understand, this was something as a completely peer-to-peer middleware that was developed in IIT Madras over a period of time. Okay. And this whole software actually is proprietary, local. The IIT Madras, DOS Lab owns the rights for this software. Okay. So what I want you to do now, I want to do an experiment. First thing is you should be able to. It's very simple. It should not take more than an hour and a half for you to be able to just run these programs and understand how this works. Okay. Right. Is that clear? Whatever I was explaining, is that clear? Are there any? Okay, right. So this is a very nice thing for you to do. You just get Windows machines. It will run on a Windows machines. It will run on a Linux machine. Anything can be made part of your system. All that you need is the jvishwa.jar, journal server.jar. Okay. Now each college should do this. Now my experiment is something different. For Vijayanagaram College, I am giving a slightly different experiment along with the other colleges, okay, to do this experiment. What you should do is you should make, this was never done before. Okay. So I want this thing to be done as part of the college experiment now, okay, which is now moving into a research level for all the colleges also. Okay. Now start the journal server in the cloud. Okay. That means you will start on a DigitalOcean virtual machine, and then you will start this journal server in the cloud. Okay. Now when you start this in the cloud, every other machine from these local other colleges can become part of the grid by just giving the IP address of the journal server which is in the cloud. Okay. I'm calling this as cloud seeding. For the first time, I'm terming this as cloud seeding. Okay. Instead of putting the journal server in the local machine, we are trying to put it into the cloud. Okay. And in fact, this experiment was done connecting Australia, some machines in Australia, some machines in IIT Madras, some machines in IIIT Bangalore, and some machines in IIT Delhi previously. Okay. And some machines in EPFL, Switzerland. Okay. This was done previously, connecting them. What we didn't do is, we didn't do a cloud seeding at that point of time. Okay. So we have machines, some machines in Australia, University of Melbourne, some machines in IIT Madras, some machines in IIIT Bangalore, some machines in IIT Delhi, and some machines in EPFL, Switzerland. Were all connected together, and we did experiments on this grid, and we published a couple of papers in Transactions on this, results of this. Okay. Now what I want to do is, I want a cloud seed to be created. That means a journal server will get created in the cloud, okay? And then all other colleges now can connect up to that journal server, whatever number of machines they want to connect up. Now you can do parallel programming across all these colleges. The prime number calculation, let us see if we can execute on how many number of machines across different colleges we are able to execute. Okay, right? Is the experiment clear? So what you will get is now Vijayanagar, yeah. So will the Vijayanagaram college will be able to start up a digital ocean instance, okay, and then start the journal server there. You should be willing to pay, okay, for that instance, okay. Is that all right? And you have to keep that instance on. Which is L3 college, which is saying hello. Okay. Venkatesh, can you respond for this? So you'll keep the instance. Since you have taken some initiative in putting it, I know that you've been following the lectures. I'm giving this extra challenge for you. Okay. So now you have to put it there and put the grid nodes in your college. The grid nodes can be across all these different colleges. Okay. Right. I want any of these colleges should be able to now fire the prime.txt, which means that we can set up a voluntary grid, voluntary cloud, okay, across different colleges, different campuses using this software. That's what I want to experiment using these colleges. Okay, is that clear now? Yes, you should also be part of the experiment. You should set up the grid nodes. All the colleges are part of this experiment, not just one college. Please understand this. Okay. It is not just one that is part of this experiment. What you should do is you should download our software. You can set up a local journal server, connect up all your machines, do a local one. Do that separately. But what you are going to do is you will also become part of the cloud experiment. Okay. Right. Hello. Yeah, good afternoon. Hmm. Okay. Yeah, sure. Yeah. Yeah, sure. Yeah. Okay. Yeah. Is the experiment clear? All the colleges are part of this experiment, not just one college. What Vijayanagaram College is going to do is they are going to start up a journal server in the cloud. Okay. Or I'll do one thing. I'll do the journal server myself. I'll start it up. Okay. And then I'll share the journal server IP address. Okay. All the other colleges, their grid nodes will connect to this journal server. Okay. No, you can't make as a journal server because they can't be multiple journal. We can start multiple journal servers, but then to start with, let us have one journal server. Okay. This software does allow you to create multiple journal servers which can all work together, but that's a different experiment. I don't want to do that experiment right now. Okay. Right. I just want to do one experiment and show you the power of this whole process. We are now trying to extend the concept of a cloud itself to a different level. Okay, this is the first time we want to do this experiment as part of this whole thing. Okay, so what we're going to do is we'll create a journal server. We'll start up this journal server and we'll share the IP address of this journal server. So all the colleges, whoever wants to be part of this experiment, can download our grid, no, our grid node software, run on their machines the grid node software, giving the journal server IP address, which we'll share with you. Okay, then you can actually be part of the grid, and then you can run the we just want to see how this will work. Okay, in fact I've used this the other day to set up for the 5 laptops in my house as part of a grid and run these programs across those 5 laptops. Now, 2 of them are Windows laptops, 3 of them are Mac. Okay, using my wireless connection, which is 192.168.0 whatever blah blah thing, I connected up those 5 nodes and was able to do parallel programming on them. So you can also independently experiment in your colleges using this software. Okay, the software is being extensively used by some people. That's why I'm bringing it to your notice, so that you know that it's possible for you to be part of the research that we do. Okay, is that clear now? Okay, so as a first step, you just download this software, okay, and then set up the thing and run the prime example, and confirm that you have been able to run this example. Next sitting, we are going to share you the journal server cloud IP address to which you can connect up. Then we can see how we can program on these multiple machines. You should be able to program, I should be able to program. So we will dedicate some 15-20 machines from I don't know, each college can donate some number of machines, and we can see how we can program on them and do some experimental results. Okay, yeah. Yeah, so yeah, is this experiment clear now? Okay, now I think we'll move on to Hadoop. I will ask the students to explain now setting up the Hadoop cluster for you in your campus. Okay, using the Bosmool stack. Have you been able to download the Bosmool stack now? They'll tell you how to set up a 3-node cluster, and then how we can start programming on the Hadoop cluster there. Once they explain and then they tell you how to set up this cluster and show you how to do a sample program on it, I will do the deeper details of how you can further experiment on the cluster. Okay, is that clear? Any questions? Yeah, I think Vijayanagaram campus has completed the setup, but I think for the other colleges' sake, we need to go through this. Okay, I think both Balaji and these people are going to explain to you now how to set up this in your local cluster. Then we will start looking at the further deeper details and the experimental parts on how we will understand programming in the Hadoop cluster. Okay, is that clear? Okay, so I'm going to ask the students, Balaji. Yeah, I think you can use this machine. Just, I think you will be in the, now you will be seeing them. You can also come this side. Okay. Now you need the this thing, right? Yes, need this will give you the, you can log in anywhere you want. Okay, from here, which are the places where you're set up, you can just log in and start. So start showing this. Keep explaining them. Yes. For a while you will feel dumb because you are going in, but then you don't see anything here. Okay, right? Okay. Keep doing this. I will also be around. Okay. 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 Yeah. See, making the, yeah. Are you able to log in?
Yes, sir.
Okay.
Virtual.
You need a virtual box where? Virtual box will be there, no? This machine has a virtual box
But I need to know the name.
for them to show. But then how are you going into those three machines?
SSH.
Then you go as SSH, that's all, no? Into those machines. You've already started the virtual machine there, right?
Yeah.
Then you just do SSH into that.
Okay.
Okay?
I thought installation from basic.
So you want to show the virtual box installation also.
Virtual
Just ask them how many of them want the virtual box installation to be shown. Okay. Just check. How many of you want the virtual box installation to be shown? Can you respond on the chat, please? Where is the link? They should download the file from this link, right? Just put the download link here. They won't, I think. No, put the full download link. Otherwise, how will they know? Understand? Otherwise, they won't know. Now you put DOS dot.
iitm.ac.in.
You just show it here. They'll see this. Just go to the website.
Yeah.
Where is it?
Some research.
Down projects. Okay. Just go there. Keep clicking.
Awesome.
This is a double thing. Okay. This is C with Hadoop. Yeah, you have to go here and then click. Okay. Then you get this VDI file. Okay. Right. Then you just go to the applications. Once you get this, get to the you have to also download the virtual box. Okay. This virtual box software has to be downloaded. Once you do this, okay, then you have to start a new one here. Just explain from here.
Yeah.
I think as it got downloaded now, in the download path it will be there.
So have you started downloading, sir?
Yeah. It's getting downloaded, so it will take time for it to get downloaded. Okay. Once they are there, then yeah, then while when it gets downloaded, meanwhile you just get into it. Once it got started, you just show it, no?
Okay, sir.
You should keep speaking, otherwise, they won't. No, you can't just speak to yourself. Okay, speak louder, and then so that they get the.
Yeah. See, please, sir. Which link, sir?
Speak louder.
Okay. Good afternoon, everyone. I would like to share the link with you where you can download that VDI images of Boss Mole along with Hadoop stack. Just give me 1 minute. I will share the link.
So yes, you all can hear me, right? So we'll just give you the link from where you can download the Bosmul with Hadoop stack. Some of you might have already downloaded. So for others, We'll give this link to you right now.
Yeah, I have shared the link with you. Check once you are able to download it or not. It is a around 15 GB content, which has that VDI image. So try to download it. Meanwhile, uh, I think Jntuk Anantapur has already done through the installation. Have you done Jntuk Anantapur? No.
So we are actually, it's a very long, it's a big file, so we are waiting for it to download. So meanwhile, we'll show you once you have downloaded the VDI and installed it on VirtualBox, which I think most of you would be familiar with. Once you install the VDI file in VirtualBox and get it booted, there's a manual inside the VDI image. So in that manual, there are complete steps to install, to how to start using Hadoop with the Boss-Mool. So what we'll do is we'll go step by step in explaining you the steps on how to configure Hadoop on this Boss-Mool image.
So first, how I will show you how to load that VDI image. So just can you see the desktop? No?
Are you able to see the desktop on which we are working? Can you respond on the chat?
Yes, we can able to see
Okay,
that.
so okay, yeah, okay.
Thanks. Here you need to select the new one and just name it whatever you want, like Mool Hadoop stack, and it is basically a 32-bit Debian derivative, Boss Mool. So you can select 32-bit Debian and just continue. You based on your requirement, you can give the RAM size also. Next, here you have to choose a existing virtual drive. Once you have downloaded that, just load it from wherever it got downloaded and continue from here. Okay, after that you just go for booting. It will directly boot from it is just a kind of hard disk, virtual disk images, so you can boot from there. Okay. Okay. In fact, I would like to log in to the three clusters we have, three node cluster we have set up here. From I will show the changes you have to make. Yeah. So first and foremost, you have to set up the you have to install Java in the Boss Mool and Hadoop stack. The Java location is /user local. Yeah, this is where the Java was installed in Boss Mool. So now you have to export the binaries for this uh, Hadoop libraries and Java bin. So just we are exporting those Java binaries and Hadoop library with this file. So you can see Java home and Hadoop home, and we are exporting the path for the binaries. So once you verified that, just gives dot that binary file Hadoop RC. Now the path got exported. The next step is you can check version, Java version. So basically the Hadoop supports from Java 6, whatever you can whichever version you want you can install, but it should be more than Java 6. So you can see the version, and next step is you have to make sure that uh, you are able to SSH through the all the nodes in the cluster. So for that we are making a passwordless login. So there are a couple of commands we have to give. Yeah, this is the command ssh hyphen keygen hyphen t rsa hyphen p. So it is already there in your manual. You can go through that once you boot from that VDI image. So once you get that public key, next you should copy that to all the nodes in the cluster. So basically the virtual image what we have sent to you is VirtualBox image. It consists of three nodes. Master one node is master cum data node, and other two are data nodes. So once you generated the key, just copy it to the all the host. That's already. Yeah, this is the command to copy the public key to all the data nodes. So here you are seeing slave here because we mapped that IP address to a slave. So basically how you can give it is you have to mention the host name, uh, sorry, username along with that IP address, like slave at whatever the IP at your location. You can give that. So it will copy that public file, that RSA public file to that authorized key or known host, so that whenever the master wants to start the daemons on the data nodes, it gets started. So in my case, now I am I have logged in into the master node. Now I can able to uh, log in into the slave just by giving slave SSH slave. No need to give any password. This is what we want to achieve through this. So if you are you clear? or shall I repeat? Shall I show the document also to you? Because the I cannot show right now because the downloading is taking a lot of time. VDI download. So if you completed setup to three instance clone creation to get three instance. Instance. I didn't get you JNTU Vijayanagar.
Is the question.
Can you repeat your question? JNTU Vijayanagar.
Chat. Repeat the question on the chat. Okay.
VD
one video to three both. We just copy paste it.
machines. Oh no, actually you have to copy that VDI image into three different machines, and then after you can boot.
Just copy paste.
Just it is just a copy paste. You have to copy that VDI, same VDI into three different machines, and then you can already I have shown you, na. Can be done.
Clone कर सकते हैं. Same thing.
Yeah, it is the same thing.
So now we show you the document.
Okay, give me 1 second. I will show that document.
Using Chrome. Drive.google. Yeah, now we'll be showing you the document which is already given to you in the VDI image. So we'll just for clarification purpose, we'll show you the document again. In the document, all the step-by-step procedure is given to how whatever we are showing you right now. Just give us a second. We'll show you the document of which is boss mule this Hadoop setup. So can you see this document? So we have completed a couple of steps from this document in the installation procedure. Now we'll proceed from where we left off.
Yeah. So the first one is we are exporting the path for binaries. So I have already shown you that. And the next thing is you have to configure the IPs for the VDI images. So whether it is manual or DHCP, you have to change that IP address and make sure that you are able to ping from one VDI image to another one. So that is about the second one. And the third thing is you have to we are mapping the IP address to some host names. So what it will you can simply use the IP address also, but for the clarity purpose we are just mapping the IP address to host names so that you can identify where the master is, which IP the master is running, and where the data nodes are running. So I will show that host file. Yeah, here we are just mapping the IP address to master. Just we are naming that MAC address. You can see these from these 3 lines. You have to make sure that /etc host for same for all the nodes in the cluster. And then next step is you have to you have to you have to give SSH. You should be able to log in from master to slaves with passwordless login, that is. So these are the 2 commands to do that. First is generating the public key, and the second one is copying the generated public key to the different nodes. So basically the first command is for copying the public key to the local machine where the master itself is a data node also. So, and you can see the third command here. You can copy the public key to by giving the username and for the slave and for the remaining slaves. So in our environment the master itself is a data node, that's why we are copying the public key into SSH of the same user. So once you have copied the public key, you should be able to do SSH to that particular host, whatever it may be, just by giving SSH host name. So previously we mapped the host name to the IP address. Now you can check just by giving SSH host name or IP address, whatever it is. So just check it. You should be able to log into that mission. Any doubts up to this? Yeah, you're asking. Yeah, you can also do that. Okay, why Mool you are asking? So up to here, is there any doubts?
Yes, I think the reason why we are using Bossmol is we want to take the operating system advantage. Mool actually is the only operating system, Linux distribution, that supports writing object-oriented wrappers. Now one of the yeah, I think the reason why this comes in is one of the ways you want to optimize the Hadoop performance is using the operating system support. Right now, we are not going to give you how many. What is that?
How many data nodes we can form?
You can form any number of data nodes. Mool is only a distribution at the kernel level, so it's similar to whatever is a Linux distribution. So what you get using Mool is an ability to intercept the calls to the operating system, which is part of the project that Balaji and others are doing. The idea there is you can experiment with the operating system level. It's more like big data for big data, which means you can collect all the information about the performing nodes and use that for scheduling. Okay, so this that's the reason why we want to use Mool for Hadoop, so that Hadoop can exploit the operating system level performance metrics for doing a better job of scheduling things. Okay, but right now you don't need to worry about this is like any other distribution. Okay, since Mool is our own distribution and we want to exploit the Mool distribution, we are giving you the Hadoop stack on Mool. Okay, it's possible for you to do more research, more student projects, which we will tell you how other projects can be done on as I go along. I'll show you. For example, last time we are discussing on late start of the reducers. We'll also show you how Hadoop performance can be improved and what are the techniques by which the Hadoop performance can be improved. And at that point, we're going to show you why this operating system is useful for you for doing a lot of student projects. Okay. Okay, I think we will stop here at whatever you've done so far. I think, okay, we'll come back next class on Wednesday at 2 o'clock and continue with this process. Okay, you can branch now. I'll just talk to them for a few minutes and then go. Okay, so what you've shown now is where the link and then where they can download stuff. Okay, and how to set it up. Okay, sure. Okay,
50% setting up your.
Yeah, so I think we can continue this in the next class. Okay, yeah. Okay, so there's one more. Can you give information about mid-exam? I think there are see the exam part is being done by the. I know that you people are all concerned about exams. Okay, what you should realize is the exam part for this is being done by the Jntuk Kakinada. Okay, so they will allow you to do the exam. Don't worry about your exam because I'm told by Jntuk Kakinada that since this is the first time they are doing this, they'll make sure you will get marks, okay, in this course as you have done other courses, okay, in your own because the exams are not being done by IIT Madras. The exams are being done by Jntuk Kakinada. So they will put it in such a way that it will focus on learning. That's more important, not just on exams. This is a special class that is being run for you, especially at the insistence of your Vice Chancellor. This course is coming to you. This is mainly for learning. Okay, the exam part will be taken care by them. Okay, they'll make sure that you don't lose your marks because of that. But just don't focus on exams and marks. This course is coming to you specially for learning sake. Please understand that. We want you to learn. And in the process, side effect is good side effect is exams and marks. And that the university has assured me that whatever normal yardstick that will be made for other courses, the same will be done here. If you're unduly worried about marks, about exams, we won't be able to do anything in this. We're not following a set pattern here because we want you to understand and we want you to learn. And this should help you to do a lot of student projects. That's how this whole course is coming to you. Okay, I hope you understand that. If you keep asking me this question, give me any information about exam, I won't be able to give. Okay, but then the university itself is looking in a flexible model. They know that they have to conduct an exam, they will do that. And they told me that they will do it in a way that you won't lose because you're doing this course. That they have told me. Okay, so rest assured, don't worry about exam. Ask the question how much you're benefiting, how much you're learning from this. That's more important. Okay, I hope you understand that. Right? Okay. Yeah, I think we will come back to this next class on Wednesday. Okay, right, at Wednesday at 2 o'clock. Okay. I'm telling you once again, don't worry about exams. It will, yeah, they're supposed to be based on whatever has been covered. They're supposed to set a paper that will should be easy for the students like any other exam that is done by the university. Okay, they're not going to drastically change it to, that's how it will be incremental. Okay, this is mainly meant for making sure that the students have good learning experience. That's the main purpose of this course coming to you. Okay. Okay.